In this video, I'm going to show you how to solve rational equations, and sometimes we'll have a fraction and a number or just a variable, and then sometimes we'll have two fractions or even three fractions. And then there's always going to be some kind of an inequality. Okay, so the first step is we need to get a single fraction. So that's really important. We need to move everything to the left side, get a common denominator, combine numerators, and so that we're left with just a single fraction and then a zero with our inequality symbol. Okay, once we have that, then the next thing we're going to do is solve for when the numerator is 0. And then we're going to solve for when the denominator is 0. Those are going to be our key points. Okay, and then from those key points we make a number line, test points, and that allows us to find our solution, which we'll write in interval notation. Okay, so let's get started. We're going to get everything on the left side and get a single fraction. That's our first step. All right, so we're going to get everything to the left side. So I'm going to subtract x from both sides, and then I need to get a common denominator. Okay, if I just have a single number or variable, I can give my number a denominator of 1, and then that allows me to get a common denominator. In this case, it'll be x. Okay, so then I can combine numerators, so 4 minus x squared all over x, and this is still all greater than 0. Okay, so step 1 is done. I have a single fraction with a 0 on the other side. Okay, that's step 1. Now, step 2 is to solve for when the I'll do that in black. So when the numerator is equal to 0, this is me getting my key points. Okay, and I can just go ahead and let's see, that's a perfect square. So this will happen when x is -2 and when x is 2. So those are my key points for when the numerator is 0. So that would give me 0 over either -2, and that would be 0, or it would be 0 over +2, which is 0. And let's kind of think back, what are we looking for here? We want when our fraction is greater than 0, right? These key points are telling me when it's actually 0. Okay, so this one tells me when my function output is actually 0. That's the numerator being 0. Okay, so in this case, I don't want that to happen, and that's only because of this inequality, right? I want that in green, right? So if that had a greater than or equal, those points would be allowable. All right, so now we're going to move on to when is the denominator equal to 0. So this is when. Okay, so that, here I'm going to scoot up. All right, so that would be when is denominator equal to 0, and that means that our function is undefined because we'd be trying to divide by a 0. Okay, so when we have the denominator equals 0, that's another key point. Okay, so now we have 3 key points. Okay, and now my next step is to write those in a number line, so -2, 0, and 2. And then I do my test points. These are something that are not those key points, but somewhere between them all. Okay, so let's do -3, -1, 1, and 3. So we just need some numbers in those intervals, either on the left side or in between or on the right side of our key points. Okay, so now we're going to test our points. Okay, so I'm going to just look at when the numerator is, let's see, and since I factored, I can actually just do the factors of the numerator. Okay, so we would have, let's see, when 2 plus x, when 2 minus x, and x. And then we're going to do our entire function. Okay, so let's look at all those. Okay, now the way this works is I'm looking at those sections in between my key points. So I like to just kind of do some dotted lines down here to kind of remind myself. Okay, so when x is negative 3, I plug negative 3 into this first expression, 2 plus negative 3, that is negative. Okay, negative 1, 2 plus negative 1, that is positive. And the rest of these are going to be positive. Okay, and we do the same thing. 2 minus a negative, that's a positive. 2 minus a negative 1, that's positive. 2 minus 1 is positive, but 2 minus 3 is negative. Okay, and now we do our x, so we've got negative, negative 1 is negative, 1 is positive, 3 is positive. Okay, and now our function, we're just thinking, okay, these are the terms in the numerator, so a negative times a positive is a negative, and then if you have a negative divided by a negative, that makes the whole thing positive. And then we have the numerator is positive times positive, so the numerator is positive. Positive divided by negative is negative. This is all positive, and this would be negative, right? Because we have a positive times a negative in the numerator. That gives us a negative up there in the numerator, and then dividing by a positive. And these are the points that we're interested in, okay? So now we're going back to our original problem and thinking, when is our function positive? Positive. That happens twice. That happens right here. That's positive, and this is positive. So we just go up and show those places on our number line. All right, and then we're going to write that in inequality from negative infinity to negative 2. Remember that negative 2 was a key point that was creating a 0 output, and since we don't have a greater or equal to 0, it has to only be positive. That is making my, this is like an open circle right there, and an open circle there, excuse me, as well. Okay, so then we have or from 0 to 2. All right, let's try another one. All right, in this next one, we've got 1 over x is less than or equal to 2 over x plus 1. So I'm going to move that 2 over x plus 1 to the left side. So I have set it equal to, or we have 0 on the right side. Now we need to get a common denominator. So I'm going to multiply this one by x plus 1 in the numerator and denominator, and this one by x. And then we combine numerators. And so I have x times x plus 1, and that's all less than or equal to 0. And so then that simplifies to 1 minus x up in the numerator and x times x plus 1 in the denominator. So then we get our key points, which happen when x is 1. That's when our function's output is actually equal to 0. And when x is 0, and when x is negative 1, that's when our function is undefined. Because we're looking at what would make the numerator 0. That gives an undefined function. And then what's our denominator, or sorry, that would give an output of 0 for the numerator. And then if our denominator is 0, we would get undefined function. Okay, so those are my key points. So I'm going to plug those in at negative 1, 0, and 1. And then I look at 1 minus x and x plus 1. And then what we're really interested in is the function itself. Okay, so these have to come down from the key points, so we keep really clear on what those intervals are. Okay, my sample points are going to be just anything that's not a key point, somewhere in between there. So we'll just do easy points. All right, so 1 minus a negative 2, that's positive. 1 minus a negative 1/2, positive. 1 minus a half, that's positive, but 1 minus 2 is negative. Okay, these are just have the same sign as our test points. Negative 2 plus 1, that's negative. Negative 1/2 plus 1, that's positive, positive, and positive. And then our functions are, let's see, given here, right? Because we have our numerator that's positive, and then our denominator is also positive because it's got negative times negative. Okay, and then here our denominator is negative, but our numerator is positive, so that gives us a negative overall. And then we have positive denominator, positive numerator. And so that's what we're really interested in, is the output of the function itself. Okay, and so then we look back and look to see what are we actually being asked to solve, right? So we look down at our inequality, and it's less than or equal. So it can be equal to 0 and it can be 0. And it can be less than or equal, okay? So it needs to be negative. Okay, so it can be in this section. Negative, okay? And then I need to think about, where do I have brackets, where do I have parentheses? Okay, so function's output is actually undefined at 0 and -1. Those have to be open circles because those are undefined, okay? And now when x is 1, that gives me an output of 0, and so that point can be contained, right? So I have a bracket. All right, so then we have from -1 to 0, or from 1 to infinity. And I always make a mistake and put my test points in there when I go to my final answer, but just make sure that those are the key points. And a nice way to check is just to pull out your graphing calculator or Desmos and just graph these. All right, so we can just graph that equation and then just double check that we're correct with our interval notation. And then we can do the same thing with our other equation as well. All right, yeah, so it's a really nice way to just double check that you got the correct interval, doing the algebra and really understanding where my function's output is 0 and undefined, and really thinking about what that symbol, the inequality, if it's a less than, if it's a greater than or equal, what that actually means in terms of the function's output. All of that's really important because the graph is not showing you when the function is undefined. So this just, nice way to verify that you're correct, but the algebra is important too.